In this video, we will discuss regarding phased array and what is the importance of phased array antennas.
First discuss regarding phased array. What is meant by phased array? Okay. So what is the use of this phased array? For example, um, let us see here. For example, in broadside array, if you use the broadside array, take a broadside array. For example, let us take three current elements are there. How you are supplying the currents? You are supplying equal magnitude currents of equal magnitude and same phase. Okay. So in this regard, how you are getting the radiation pattern? You are getting the radiation pattern in 90 degrees direction and 270 degrees direction. Let us now take end fire array. Now let us take here end fire array. If you take the end fire array, for example, let us consider three current elements are there. 1, 2, 3. What is the supply we are providing? For all the three elements, we are providing currents of equal magnitude, but with the different phases. Okay. So now what happened to the radiation? Now the radiation has shifted to 0 degrees. Now the radiation has shifted to 0 degrees. Means, for example, here what is the only change you have made between broadside array and the end fire array? Here you are providing equal magnitudes. Here same phase, but here the phases are changed. Means if we change the phases, okay, by controlling the phase of the currents, what you are supplying to the antennas, phase of the currents, what you are supplying to the antenna. I can make my antenna to radiate in 90 degrees. I can make my antenna to radiate in 0 degrees. So can't I make to radiate in other direction, that is in 70 degrees, that is in 60 degrees, that is in 50 degrees? Yes, you can make. How? Only by controlling the phase. Simply by controlling the whatever the current elements are there, by controlling the phase, okay, you can make the antenna to radiate in 70 degrees, you can make the antenna to radiate in 60 degrees, you can make the antenna to radiate in 50 degrees, you can make the antenna to radiate in 130 degrees or in any direction. Okay. So see here, for example, our India is there. Let us consider here India is there. Okay. For example, any aeroplane is coming from Pakistan. Okay. For example, if my radar or antenna system is radiating and only testing in this direction. Okay. Means, for example, let us consider my antenna is radiating only in 30 degrees direction. Now the Pakistan plane or any army missile is coming in 60, for example, 10 degrees. Okay. What happened? My antenna is always checking in only in 30 direction. So will it detect the missile from 10 degrees? No. So it will come and destroy our India. Okay. So that's why if you observe in this diagram, there will be continuous monitoring. This radar will check in this direction. It will keeps go on fluctuating in this direction, like this. Okay. So means how that signal will radiate or applicable in all the directions. So simply means, for example, I will take three connections. Okay, like this. Okay. For this set of antennas, I will make the progressive phase shift as 30. Another three antennas I will make for 60 degrees. If I change this one for 10 seconds, I will keep for this antenna. For other 10 seconds, I will keep for 60 degrees antenna. Then you can be able to generate the signals in 30 degrees, 60 degrees in any direction. So that is the concept of phased array. That is the concept not only in 0 degrees direction or not only in 90 degrees direction. You can generate the pattern in any angle in between 0 less than theta less than 180 degrees simply by controlling the phases of the current what you are providing for the antennas. Okay, so this is the concept phased array. Okay, in case of broadside array and endfire array, the maximum radiations can be obtained by adjusting the phase excitation between the elements in the direction normal and along the axis of array. So in means other words, the elements of antenna array can be phased in a particular way. So we can obtain an array which gives maximum radiation. So very, very important. So we can obtain an array which gives maximum radiation in any direction by controlling the phase excitation in each element. Such an array is called as phased array. Such an array is called as phased array. Okay, so the array in which the phase and amplitude of most of the elements is variable provided the maximum radiation. Okay, so this is okay. So means simply if you control the phase. Okay, so I have already told the phase difference. What is this phase difference? I is equal to beta d cos theta. This is due to path difference, and this is due to phase difference. Okay, so phase difference. Okay, so if you vary the value of phi alpha, if you vary the value of alpha, you can generate any signal to radiate in between 0 to 180 degrees. Okay, so it is clear from maximum radiation can be achieved in any direction if the progressive phase difference between the elements is controlled. Okay, so how can you control that? Okay, so the electron phased array operates on the same principle. Okay, so if you take a radar, continuously it will check in this direction, check in this direction, check in this direction. How it is possible? Okay, so this is, let us consider this is a phased array. Here, for example, let us three antennas are there. One, for example, one. This is a set of 1, 1, 1. Okay, this is one set. For this, they have fed with 30 degrees. Another set they have fed with 40 degrees. Okay, so for 5 minutes they will connect the switch to this antenna. For another 5 minutes they will connect the switch to another antenna. So what happen? In for 5 minutes it will radiate. For 1 minute it will for 1 second it will radiate in that direction. Next, automatically the switch is connected to the next thing. It will radiate in other direction. Okay, so this is one arrangement. This is one arrangement. This is one arrangement. Okay, so this is one arrangement for arranging the phase array with mechanical switches. Okay, means I can connect to 1 or I can connect to 2. If I connect to 1, it may radiate in one direction. If I connect to 2, it may radiate in two directions. If I connect the other 4, 5 other feed point switches, if I connect to 3, if I connect to 4, if my switch is connected to anything. Okay, so depending upon your requirement, it keeps on generating the signals from the angle 0 to 180 degrees. Okay, so this type of arrangement we call it as phased array with mechanical switches. Okay, here continuously switching from one circuit to another circuit with different phase shifts will take place here. So there is another type. Okay, so here this there are another type which also provide the same scanning. One is frequency scanning array, and the other one is retro array, and the other one is adaptive array. Okay, so now let us study what is going to happen in the frequency scanning array. Okay, the first one is the phased array with mechanical switches. Okay, now let us go to the second one. What is the second one? Frequency scanning array. So in this frequency scanning array, here also the same arrangement. These are different antennas. These are different antennas, and they are separated by distance d. They are separated by the distance d. Instead of that physical switches, what you have used here, the circuit will complex that. Okay, now we are going for frequency scanning array. Okay, so here in this, the array in which the phase changes is controlled by varying the frequency. By varying the frequency, okay, it is the found as to be simplest phased array at each element separated by. Here at a phase control is not necessary. Okay, so this is the phased array. Here all the antennas are get terminated at this direction line. This is here in this phased array, you are using directional couplers. Okay, you are using directional couplers. So each element of the scanning array is fed by a transmission line via directional coupler. Okay, so the directional couplers are fixed in position while the beam scanning is done with frequency change. Okay, so to avoid reflection and to obtain pure form of traveling wave, the transmission line is properly terminated of the load. So this is properly terminated of the load in order to eliminate the reflection. Okay, so the main advantage of the frequency scanning array is that there will be no moving parts and no switches and no phase shifters are required. Whereas in the previous case, you want to continuously switch to one device, switch one again, after some time switch to again, you want to switch to after switch 3. Okay, so this is not required. This is not required in the case of this one. Okay, in the case of frequency scanning array. In the case of frequency scanning array, here the directional couplers are used. These are all the directional couplers. These are all the directional couplers. Okay, so this is the thing. Okay, so another one is called as a retro array. Another one is called as the retro array. So the array which automatically reflects the array which automatically reflects the incident signal is called as the retro array. So it will act as a retro reflector, similar to the passive square corner reflector. This means the wave incident on the array is received and transmitted back in the same direction. In other words, each element of the retro array radiates signal which is fluctuation conjugating of receiving array. Okay, so this is a simple Van Atta array. So here the first element and eighth element are combined. The first element and eighth element are combined by this wire, and similarly second element and seventh element are combined by this wire, and third element and sixth element are combined by the wire, and fourth element and fifth element are combined by the cables with the equal length between pair of elements. Okay, so this is, so here all our connections, the pair is formed between 1 and 8, 2 and 7, 3 and 7. Okay, so if the wave arrives at an angle, say, then it will get transmitted in the same direction. Okay, so the array which automatically turns the maximum beam in the desired direction while turning the null in undesired direction is called as adaptive array. So the last one, we have seen the 3 types. What are the 3 types? The first one is frequency scanning array. Second one, first one is this one, phased array with mechanical switches. This is the first one. This is the second one. This is frequency scanning array. And this is the third one, Van Atta retro array. Okay. And the fourth one, what we have discussed in the period is adaptive array. Adaptive array means, okay, which changes automatically. Okay, so array which automatically turns the maximum beam in desired direction while turning the null in undesired direction is called as adaptive array. Okay, now latest technologies. Okay, so in modern adaptive arrays, the output of each element in the array is sampled, digitized, and then processed using computers. Such arrays are called as smart arrays. Okay, so this is the thing regarding phased arrays. Okay, means by using phased array, not only you can generate any signal in 0 degrees or 90 degrees, by controlling the phase of the currents what you are providing, you can generate any signal in any direction. Okay, any direction. Okay, this is all the thing regarding phased array. Okay, now let us go to